Okay, so there are two types of torospherical head also: flanged shallow disc and flanged standard disc. Okay, so here everyone got this point that the most efficient will be hemispherical. Okay, the most efficient will be hemispherical. Okay, it can sustain a very high pressure, means for high pressure we are going to use this. Okay, because it is curvy in nature, and we know that when we are going to make something curvy, yeah, okay, it has a high cost. Okay, so best examples are bullet trains. Okay, if you see that the engines of bullet trains are curvy, okay, aerodynamic in nature. If you see aeroplanes, they are more aerodynamic. If you see the fighter jet planes, if you have seen Rafale and all that, okay, so they are more aerodynamic in nature. Okay, so it cost us lot much. Okay, so to increase the speed and all that, so it is going for high pressure. So if you are seeing the same pressure, if you have a same pressure in all hemispherical, ellipsoidal and torospherical, so which will be have the thickness least thickness? It will be of hemispherical. Okay, obviously, because if you want to use a torospherical for a high pressure, you have to create a very huge thickness of that. Okay, you have to make a very huge thickness of torospherical. Okay, I'm not talking about here construction cost. Okay, I'm just talking about thickness. Yeah, construction cost, you can say that for hemispherical is more. Okay, because making something curvy, it will be more. Okay, so because if you make something curvy, you are going to uh, save a lot of amount of money. Okay, so you can say basically it is optimization, because if you see it is a bullet train, so can there is one thing also, that why in India we use a rectangular shape engines. Okay, you can go for a that aerodynamical engines. The answer is because in India, you will see in fluid mechanics also, because in India we are not our trains are not moving at a very high speed. Okay, where our trains are not used for a very high speed. Okay, the speed is very less. If you see in Japan, China and all there, they are operating at a very high speed. So that is why the drag is more dominating at a very high speed. At low speed, the drag is very less. Okay, so that points you will going to see in the fluid mechanics. Okay, you will see in detail. Okay, so torus spherical heads, you can say where the pressure is very less, or you can say it is atmosphere or 2 atm or 3 atm. So we are going to use a torus spherical head. Okay, so this is the thing about the heads which we are seeing. Okay, so we are done with the vessels. Okay, I'm not saying that what we have covered is the 100%. There are so many things. It's in detail. I told already that it make a very detailing, but that is under when you are going to a designing anything. Okay, nobody is going to ask you in detail, because it is not under chemical syllabus. It is actually this design of pressure vessels, and this all that's more about the mechanical engineers. Okay, mechanical engineers design this actually in the industry. We are more interested, chemical engineers are okay, chemical engineers are entered because material of construction is very important. Okay, so that is why there is a work of chemical engineer. Okay, this. Okay, so that is the thing. Okay, so there are designing substance. Okay, we have in BTech SOM. Okay, we have basics of SOM. Okay, we have basics of this plant equipment design subject. Okay, where you will actually design in the flow sheet and all that. Okay, so still that is also not in so much detail. Okay, okay, next is the support for pressure vessels. Okay, next is the support for pressure vessel. Next is the support for, you can write, pressure vessels. Okay, so support for pressure vessels, you have seen, you can't directly put the pressure vessels onto the surface. Okay, you have to give them support. So that support will take care that they will not come in contact with the water directly, their basement. Okay, so that it can sustain a high wind velocity. So there are various factors. So for that we have to give the support to them. Okay, so it depends upon that which support you are doing for whether your equipment is vertical or your equipment is horizontal. Okay, so first we will see vertical equipment. Vertical equipment. Okay, so vertical equipment, first you can say skirt support. Okay, skirt support. So skirt support is nothing but at the bottom basically. Okay, at the bottom we will give you some space. Okay, so skirt support is nothing but, suppose you have a equipment like this. Okay, sorry, I will try to make a proper diagram. Okay, suppose your equipment is like this. So at the bottom what you will do, there will be the, you can, this can be made up of cement, rock, or any metal object also, you can say. Okay, some like this. Okay, you can just imagine in 3D that it will be on this and this, like this. Okay, so this is skirt. Okay, so to give you the, in that it will be fixed, so it is like support. Okay, so this will be skirt support. Okay, black one is your equipment and blue one you can say basically it is a supporting like that. Okay, so basically these are most suitable for the taller vessels. Okay, okay, because you give a very major loading here. Okay, you can see the images actually in Google's actually, so that will clear you more. Okay, what is that? So I will give you the names. First one is the skirt support. So these are more suitable for, most suitable for taller vessels. Okay, so draw this diagram. You can. One, stiffing and reinforcement. It is not in the gate syllabus. Okay. Okay, I don't know why they have given. Okay, so lug support. Okay, lug support is basically, second one is the leg support. So lug support is basically like that, you can say. Okay, suppose this is your vessel and you are supported on something like this. Okay, your support is here. Yeah, the spelling is L-U-G, lug. Leg is different. Okay, this is lug. So it will be supported here something. Okay, something will be there on the wall and it is wall mounted like that. Okay, so it will be lug support. Okay, third you can see Okay, third you can see basically, okay, so basically this lugs can be mounted on the wall, or can they have a leg, so that is known as leg support. Okay, so how leg support will work, it will be like this. So it will be like this, and you have to make a lug here. Okay, and there will be the legs. So this, in this side there will be also the thing will be there. This will be like this. So this is leg support. So what is lug here? This is lug. Okay, this part is lug where it is supported. So you can do the wall mounted also thing. Okay, means you can attach this. It is just like fire extinguisher. Okay, so they have like it is not totally a fire extinguisher, but small thing which is there, which is kept, is used to keep a fire extinguisher. You can say that is a lug. Okay, so this is lug. And sometime directly the you have seen the fire extinguisher. Okay, fire extinguisher, it is placed on ring support. It is placed on ring support. So how will ring support will be there? It will be like this. Okay, so your equipment is inside that. So this will be your ring support. Lug is something which is there, which is attached to that. Okay, so that lug can be attached to the legs also, or it can be directly attached with the wall having some nails. Okay, so that is a something. Okay, so that is lug, means something which is coming out of the that pressure vessel. Okay, and you will have that. Okay, some hook is there. Okay, so draw this diagram and write this. Proper notes means what exactly you want, 210, 210, 319. There is no theory here. Okay, so just diagrams is there. Okay, I can just explain the diagrams how support is there. Okay, ring support. See, ring will be like this. When you will insert something in that, it will be tightened by the, okay, it will be tightened by the, you can say, any screw. Okay, any screw it can be tightened. After inserting in that, it can be tightened by the screw. 210319, you can see images on Google, you can easily understand. These names are important. Okay, I'm not saying that these are the only four types of supports in the world. There are 100 types of supports in the world. Okay, but these are the frequently used. So you can just write down these names. Okay, visualize, that's why I told. Now you can just see the images on Google. Okay, on that. Okay, I can't make a 3D objects here. Yeah, 21138. Ring support is like ring only. Okay. you can see. So everything is fine with this vertical equipment support A, B, C, D. So these are the four types which we use. So it is comfortable or not? Okay, you can give the feedback actually. Is it comfortable? You can know the names and I'm just trying to draw the diagram, or you can. See, this is not in GATE syllabus. Okay, this is I'm just telling regarding the interviews. Okay, this is very important from interview point of view. Okay. Okay. Now we are going to see a horizontal. Okay. Now we will see if you see. Okay, for I will draw all the diagrams on one setup. This is 2, 3, 4 we have seen. Okay. So what is skirt? Skirt will be at only the bottom. Okay, so it will be only give you support in the bottom. We have seen lug. Lug is just a hook. Okay, there will be the hooks. Okay, here. So that can be horizontal. You can put it on the wall also. If there is a hook, you can put a legs to here. So then it is a leg support. And this is ring support. Okay, so inside anything ring, it will be like this. Okay. Now we will have a horizontal support. Horizontal support, basically you can say the most famous is the saddle support. Okay, so saddle support is basically for the heat exchangers. It is like this. Okay, saddle support. So it will be somewhat curvy from here. So it will be like this. Okay, so you can remember the point saddle support, which is most frequently used for heat exchanger. Okay, you can write this point. Okay, yeah, sleeping vessel you can say. Stresses in tall vertical vessels. Okay, I will see that what is given there. Okay. Okay, this is saddle. Similarly, there can be leg support. So it is nothing new in that. Leg support, there will be the legs. Okay. And there can be a ring support. So how ring will be there? It will be like this. Okay. So you will make a ring here and they will have a support like this. Okay, so these are the most frequent horizontal support. Okay, now you can write this 210319 stresses in tall vertical vessels. Okay, actually most of the points which you are saying, it is not in the GATE syllabus. Okay, I will be first covering which is very important from GATE point of view and interview point of view. Okay, after that I will be covering if time is there. Okay. Okay, roll number 210319. See, the thing is that okay, it's okay. Thank you for that feedback. But thing is that economics part I have taken totally from gate point of view. Okay, and this pressure vessels and some other topics which I am going to take you, I can't go so much in detail. Okay, because the weightage of this is only 1 mark. Okay, so I have also some time limitations. According to that, I have to teach. Okay, for you can say BTech point of view, this is important subject, but from interview point of view, it is somewhat I will be covering some points, but from gate point of view, the weightage is only 1 mark. Okay, so that is why. Bark interview, I'm telling na, Bark interview, they will just ask the support and all that. They will not go in detail in this subject, designing part. Okay, in Bark interview, they will be going in detail in mass transfer. They will be going in detail in PDC subject. They will be going in detail in CRE subject. Okay, they will be going in detail in heat transfer subject. Mostly they prefer this four subject. Okay, they will be not going in detail in this designing part. Okay. And fluid mechanics also, yeah, obviously fluid mechanics. Okay, because these are the core of chemical engineering. Okay, you are basically you are not going to design a pressure vessel in the industries. They are mostly done by the mechanical engineers. Okay, just we have a some little bit knowledge regarding that. Okay, so our core subjects will be CRE, mass transfer, heat transfer, fluid mechanics, thermodynamics. These will be the points you have to go. Okay. Yeah, yeah, that I can do. Okay. There is no notes. See here, what? So can you tell me that what notes I can give here? There is a saddle support which is used for heat exchanger. That's it. Okay. There is no notes here. You have to remember the name: saddle support, leg support, ring support. Okay, that is the thing. And in interview they can ask you that how is they look. Okay, approximate how they look, they can ask you, they can give you the pen and they can ask you that draw this. Okay, that is the only thing they can ask you from this subject. Okay, no, they are not going to ask you the process of manufacture. Okay, they are, how they can ask you that how you will manufacture a saddle support? Is this the work of chemical engineer? No, they will not going to ask you. Okay, you can ask to any senior or anyone. Okay, in PSUs they are not going to ask you. Whatever I am teaching, I have, that's it. If you have this knowledge, it's okay for interview point of view. Okay, we chemical engineers don't design this in so much detail. Okay, so this is done by mostly mechanical guys and all that. Okay, so what they have asked, roll number 211382. Up to that you can solve one question actually. In a, yeah, you can tell me the questions. 211382. In a cylindrical vessel, subjected to internal pressure, internal pressure of the longitudinal stress and lateral stress are related by, so they have given option sigma h equals to 2 sigma L, B equals to sigma h equals to sigma L, C equals to sigma h equals to sigma L by 2, and D equals to none of these. Okay, so the correct answer is option A. Okay. Next question. The term knuckle radius is associated to torospherical, flat, hemispherical, none. So the correct option is, okay, 1, 2, 3, 4. This is fourth. So correct option, yes, it is torospherical. Okay, it is torospherical. We have seen in the theory. Okay. Next question. A cylindrical pressure vessel of volume 6 pi meter cube has to design a cylindrical pressure vessel of volume 6 pi meter cube has to be designed with beta with internal pressure of 10 atm and allowable stress, okay, allowable stress lateral equals to 125 Newton per centimeter square, and corrosion allowances is 2 mm. The thickness of the vessel for a L by D ratio equals to 3. Okay. So the thickness of the ratio for the vessel of L by D ratio equals to is dash. Okay, so calculate this. Secant, it will be same. Okay, for ellipsoidal, both are same. Nakal and that 220106. It is only for toro spherical. Okay, that term nakal radius and all that. Because for others, there is no term for that. Okay, because it is curve from starting itself. Okay. So write this question. So this is the first question you can write. Okay, this is the second and this is the third one. Solve. Okay, solve this. Calculate this. So many students are giving wrong answer. Calculate in mm. Okay. Tell me answer in mm. Yeah, only one student got the answer correct. That is 211.76. Last 2 minutes, solve that question properly. Solve this properly. Everyone got the answer? Attempted the question? Yes, 210319. Okay. So see, answer. What is the formula for us? T equals to PD by 2 sigma H. Okay. So that is the thing we are getting here. So if you solve in this, it will be how much we are getting? 10 ATM is given. So 10 into 101325. Okay. This is the thing we are getting here. So everything, yeah, and here it will be 2 into 125 into 10 to the power 6. Okay. And what will we will place in terms of D? It is given V equals to pi r square L. So V is pi by 4 into D square into L. So they have given it is 6 pi. So from here D equals to how much it will come? Calculate. So they have given the ratio. So it will come, I think, 2. Yeah. So it is multiplied by 2. Okay. Everything is fine or anything, right? 6. How much I have? Centimeter. No, okay, okay. So it will be 4. Now it is fine. or anything wrong I have taken? So how much answer is coming? Yeah, corrosion allowance we have to add. Wait. Okay, sorry, I have given wrong units actually. In the gate, it is mm². Okay, solve it for mm². Okay, solve it. So now I think it will be, okay. So now it is coming 10 to the power 6. That's why students are writing 10 to the power 6. Okay. And this answer will come 8 mm. Okay. Plus 2 mm corrosion allowance is given. So total will be 10 mm. Total will be 10 mm. Okay. Okay. See, in terms of diameter, or you can write it in terms of radius. What is this? Means, huh? You can't write in terms of diameter. You solve it in terms of radius because it is given in terms of diameter. That's why. So what is a big deal? In this formula, instead of radius, it's diameter. Why? So you can take it, na? Means this is okay. Please see this. Means yeah. Means in place of if I'm taking diameter or radius, there is not a big deal in that. Okay. Okay. No, you should don't apology, but please take care questions. Okay. Such mistakes means we do, means I have also done these mistakes. Okay, there is nothing that we being a human being we do these mistakes. Okay, I have also in my btech I have done this mistake. Okay, whether to take diameter or radius, but be focused on this. Okay, because this small mistake if you do, then it will be difficult. Okay, because that makes a question wrong and this will be there. Okay. Here just to see na, pi will cancel it out. Pi is cancel out. Okay, here you take d and they have given ratio l by d. You just put the ratio here, you will get d equals to 2. Okay, Class? No, class will be up to 8 o'clock only. Who told it will be 10? Okay, so that is D here. Okay. Everyone got this problem? Everyone is clear?